Antarctica, a continent of ice and mystery, holds a secret that could reshape our world. This secret lies within a colossal river of ice known as the Thwaites Glacier, ominously nicknamed the Doomsday Glacier. The Thwaites Glacier is a behemoth, a giant frozen river flowing into the Amundsen Sea. Its sheer size and precarious state have placed it at the forefront of climate change research. The glacier acts as a cork in a bottle, holding back a vast amount of ice that could dramatically raise sea levels. Scientists around the world are working tirelessly to unravel the mysteries of Thwaites, using cutting-edge technology to study its behavior and predict its future. The fate of the Doomsday Glacier is intertwined with our own. As we delve deeper into the story of the Doomsday Glacier, we will uncover the science behind its melting and the potential consequences of its collapse. The Thwaites Glacier is located in West Antarctica, a region particularly vulnerable to climate change. It's a massive ice stream, roughly the size of Florida, draining into the Amundsen Sea. Thwaites is dynamic and fast-moving, moving several kilometers per year. Its grounding line, where it transitions from bedrock to ocean, is critical for stability and melting rates. Thwaites has a unique geometry, making it susceptible to warm ocean currents. Understanding these traits helps predict its impact on sea level rise. The Thwaites Glacier is melting at an alarming rate, and the primary culprit is climate change. Rising global temperatures are warming the atmosphere and the ocean, creating a double whammy for the glacier. Warmer air temperatures contribute to surface melting, while warmer ocean waters are attacking the glacier from below, accelerating its retreat. This dual assault is destabilizing the glacier and increasing its contribution to sea level rise. Circumpolar deep water, a relatively warm layer of water in the Southern Ocean, is reaching the base of the glacier through channels and cavities in the bedrock. This warm water melts the ice from below, causing the grounding line to retreat. As the grounding line retreats, more of the glacier becomes afloat, further accelerating the melting process. The melting of the Thwaites Glacier is not just a local phenomenon, it has global implications. The potential collapse of the Thwaites Glacier poses a significant threat to coastal communities worldwide. A rise in sea levels would displace millions of people, inundate low-lying areas, and increase the frequency and severity of coastal flooding. Major cities like New York, Shanghai, and Miami would be particularly vulnerable, facing increased risks of storm surges and permanent inundation. The economic consequences of sea level rise would be devastating. Coastal infrastructure, including ports, roads, and buildings, would be damaged or destroyed. Beyond the direct impacts on human populations, the melting of Thwaites would also have far-reaching ecological consequences. Rising sea levels would threaten coastal ecosystems, including mangroves, salt marshes, and coral reefs. The interconnectedness of Earth's systems means that the melting of Thwaites could have ripple effects across the globe. Scientists are constantly monitoring the Thwaites Glacier to study its behavior and predict its future. Satellite observations provide data on the glacier's surface elevation, flow rate, and grounding line changes. Airborne surveys with radar and laser altimetry measure ice thickness and bedrock topography. Recent research has revealed alarming discoveries about the Thwaites Glacier. Studies show the glacier is melting faster, with warm water penetrating further inland. Large cavities beneath the glacier indicate accelerating ice detachment from the bedrock. The International Thwaites Glacier Collaboration, or ITGC, is conducting extensive research on the glacier. The future of the Thwaites Glacier remains uncertain, but the current trajectory is concerning. Continued warming of the atmosphere and the ocean could lead to the glacier's rapid disintegration, contributing significantly to global sea level rise. The potential consequences of such an event are immense, posing a serious threat to coastal communities and ecosystems worldwide. Understanding the future of Thwaites requires ongoing monitoring and research. Scientists must continue to collect data on the glacier's behavior, using advanced technologies and innovative techniques. Mitigating the risks posed by the melting of Thwaites requires a global effort to address climate change. Reducing greenhouse gas emissions is crucial for slowing the rate of warming and preventing the worst-case scenarios. The future of Thwaites is not just about the fate of a single glacier. It is about the future of our planet and the well-being of future generations.